Hi guys, in this chapter we will understand about related rates, which is a practical application of differentiation that we have learned so far. So what is related rates? By definition, related rates is the application of differentiation in real life situation. What does it mean? In the related rate problems on the AP Calculus AB exam, you need to figure out how fast one variable is changing when you know the rate of change of another variable at a specific point in time. Okay. For example, how fast is rocket rising up at a particular height? So it has reached at 100 meters. How fast is rising at 100 meters? Or if it reached 3 kilometers, how fast is rising at 3 kilometers? So that's like rate of change of rising. You're pumping air in a balloon and the balloon is growing. Does it grow at the same rate? No. So how fast it's growing when the radius is 1 meter versus the radius is 5 meters? At 5 meter, logically speaking, it would be growing a little bit less faster than compared to 1 meter, right? If the pump is flowing the air at the same rate. How fast person's shadow, if he's moving away from a lamp post, is increasing. If the person is walking away at a velocity v, how fast is the shadow changing? So these are all the practical applications of differentiation. Let's try to understand it better with one of the examples. So water is leaking on floor and forms a circular pool. The radius of the pool increases at the rate of 10 centimeters per minute. Okay. How fast is the area of the pool is increasing when the radius is 10 centimeters? Okay. So let's try to draw a diagram to understand a little better. So water is flowing on the floor. So and it's making a circular pool. So let's say at instance t1, the circular pool is like this with radius r, right? After some time at instance t2, more water is flowing, so now the radius is r2 at t2 time. Similarly, more and more water is flowing, so radius is increasing. With the radius, the area is increasing as well, because we know area of a circle is nothing but pi r square, right? So we have to find out how fast is the area of the pool increasing when the radius is 10 centimeters. Okay, we will use the implicit differentiation. So we know the formula. Area is equals to pi r square. Now we want to find out a particular moment in time, how fast is the area increasing. So we will differentiate both the sides with respect to variable time. So we can say dA over dt is equals to d over dt pi r square. Pi is constant, so we can keep pi out, and now we are left with d over dt of r square. What is that? Which is equals to pi times 2r times dr over dt. Okay, so that's the rate of change of area with respect to the rate of change of radius. Let's plug in the values, which is equals to, let's say, pi times 2 times, what is r? R is 10 centimeters. Be very careful. If you want to maintain a particular unit, maintain it throughout the calculation. If the answer is expected to be given in meter per second, then it's good to convert everything to meters before you start plugging in the values. But in this case, it's not that important, because we can still find based on centimeters per minute, because radius is given as centimeter per minute. But in general, you should be careful. So what is this radius when we want to calculate the change of area? Radius is 10. What is changing the radius? Radius is changing at the rate of 10 centimeters per minute. Okay, so I'm going to put 10 here as well, which gives me 200 pi. 200 pi, because it's a rate of change, so it will be centimeters square per minute. Or we can calculate further. Pi is nothing but 3.14, so it would be 6.28 times 100 centimeter squares per minute, which is nothing but 628 centimeter square per minute. Now, are we done? For the calculation part, we are done, but this is AP calculus. They expect the answer in the sentence form with proper vocabulary of increasing, decreasing, etc. So let's try to write it. So we know that, so question is asking, how fast is the area increasing? So we will say, let's try to write it here. Answer will be, the area is increasing at a rate of 628 centimeter squares per minute when the radius is 10 centimeter, that I got from the question. Okay, radius is 10 centimeter. So this is how we will answer in the AP calculus exam, because they require the proper vocabulary that we use. The rate is increasing or area is increasing at what rate and against what, when the radius is about 10 centimeter. We will do more sample questions like this in subsequent videos to understand it better and practice some more questions. Let's Thank you so much. Let's meet in the next video.